Okay, in this video, we will talk about the intuition behind the merge sort algorithm. Okay, so if you remember from my previous videos, we talked about insertion sort algorithm, right? And over there, we have taken an approach called incremental approach. So let me write it down over here. Okay, so we have taken for insertion sort algorithm and incremental approach. An incremental approach where what we have done, we basically from a given array, we basically taken an element over there and we just place it over there, right? So from a given array, okay, we have taken a particular element, okay, and place it in right place, okay, using our insertion sort technique. Okay, using our insertion sort technique, okay, to sort the given array, right? To sort the given array. Now over here, given array, right? Now if you see it over here, we have this approach is incremental in nature, right? That means in each and every iteration, okay, so we have taken a particular element in each iteration, iteration, in iteration, and place it, right? So if I just write it down and place it in right place, so we have taken an incremental approach there, right? Now there is another approach called divide and conquer approach. Okay, so if I just take another section over here, it's called divide and conquer approach. It's QUER. I'm always bad with spelling. Okay, so in divide and conquer approach, what is happening is the approach is completely different from this incremental approach. Okay, where what we have done, we basically do this stuff. We basically divide this whole problem, okay, whatever sorting problem or any kind of algorithm. Divide and conquer can be used in any kind of problem. Okay, and so basically we divide this whole problem, divide the whole problem, okay, problem into small problems, okay, into small problems which are similar in nature. So this is important, okay, which are similar in nature, which are similar to the actual problem. Okay, so when we will be dividing it, okay, so you have to remember that the small parts, right, the small parts we are dividing, the nature of that part, like the way we will be solving those small parts, right, we will be solving in recursive way. That means it is necessary that those small parts, the nature, that means if I talk about a sorting problem, okay, so that means we will be dividing this whole whole array into small sub arrays, okay, so that we will try to sort them as well. Okay, so even like when we will talk about any other kind of problem, the small sub problems has to be similar in nature in compared to the whole big problem. Okay, so this is one thing. We first divide the, I'll just mark it as a different color, okay, so that you will remember this one. So we divide the whole problem into small similar problems, okay, and then we conquer it. That means we solve in the conquer. In conquer, what is happening is, so I'll just color it again. Okay, so in conquer, what is happening is we basically solve those small problems, problems, okay, problems using some recursion method, recursively. Basically we will be doing again and again, right? So basically we will be trying to execute the similar codes again and again to solve these small problems over there. Even when in future videos I will be discussing about the analysis of this algorithm, right? We'll be discussing about the pseudocode as well. That time it will be more clear, okay? Here we will just take the intuition of it, okay? So solve those small problems recursively. That means the way we will be solving is a particular small problem, it will be similar way we will be solving the other small problems as well, okay, recursively. Then the last step of this particular approach is the combine approach, okay. In the combine approach, again I will just try to color it out. Okay, in the combine approach, what I have done, we basically combines those small solutions, okay, we solve those problems in the conquer steps solutions to get the final solution, okay. So in divide and conquer approach, this is the whole, if I just take a bird's eye view of the divide and conquer, so this is what happens over here, okay. So we basically divide the whole problem into small sub problems which are basically similar in nature, okay. And in conquer, what we are doing, we basically solving those small sub problems, right? Small sub problems recursively, okay, sub problems recursively, okay. And then in the combine step, we basically combining those small solutions to get the final solution over there, okay. Now merge sort is basically following this approach, divide and conquer approach, okay. Divide and conquer approach, QUER approach, okay. So if I just if I just go by this particular approach over here, so in the divide stage, what we can do, we can basically divide this input array, okay, into small sub arrays over there, okay. In the conquer approach, we basically solve those small sub arrays, basically sort them, right? Because we are dealing with a sorting problem over there. So if I just write it down over here, so in the divide stage, what we do, we basically divide the input array into sub arrays, okay, sub arrays over here. Now generally, if the input array size is n, so we generally create n by 2 lengths, okay. So lengths 2 sub arrays, 2 sub ARRAYS, so 2 sub arrays over here, right? Generally we will see like how to deal with other stuff as well over here, okay. So this is in the divide portion, we just divided the input sub array into n by 2, okay. Now in the conquer approach, what we do, we basically use a merge sort technique. We use a merge sort technique, okay, to sort. Basically we'll just try to write it in sorting terms only, to sort this sub arrays, okay, to sort these sub arrays. Now the merge sort technique, we will be seeing it very soon now, okay. We'll take a intuition as well for the merge sort technique, and then finally we will combine as well, okay. Even this merge sort technique, it will help us to combine those array results as well over there, okay. Finally we will combine. So merge sort technique is basically applicable for these two guys as well, 2 and 3 over there, okay. So So now let us talk about this merge sort technique over here. Okay, so one thing we have to remember, okay, when you talk about this merge sort technique, is it always work on arrays which are already sorted. That means when we try to merge those two arrays over there, those input two arrays has to be sorted. Okay, that means merge, it assumes that the input arrays are already sorted. Okay, that's the requirement for this one. Now we have to fulfill this requirement as well, right? So for a given problem, how we will fulfill this particular requirement, we will see it now. Okay, for that what we will do is we will take an example now. Okay, for that what we'll do is we'll just create a very simplistic diagram over here, and we will try to reason through it. Okay, so let me just try to create a hierarchical diagram. Maybe that should be sufficient enough for our own idea over here. Okay, let's say we will start with an array with these elements 5 comma 2 comma 4 comma 7 comma 1 3 2 6 1 comma 3 comma 2 comma 6. Okay, so we have this many elements over here. Okay, so I'll just try to make it better, big one. Okay, so we just started with this one. Now if you see it over here, according to the divide and conquer rule, we have to first divide this array into two arrays. We call it left array and right array over here. Okay, so now, and when we'll apply the merge technique, only when the arrays are already sorted over here. Okay, so as we have 4 and 4 8 elements over here in our array, right? So we'll divide this array into two sub arrays. Okay, one sub array will be 5 comma 2 comma 4 comma 7. First 4 elements I have taken. Okay, the second sub array we can take 1 comma 3 comma 2 comma 6 over here. Okay, so we just divided this main array into two sub arrays over here. If you see, this sub array is not sorted already. Even this one is also not sorted. Now when we talk about sorted, right, by default I will mean like from the lower number to the higher number over here. Okay, that means ascending order. So that means I cannot still apply merge over here because this is not sorted, right? So let's try to break this one as well. So we have 4 elements over here, right? I can divide it 2, right? So I will say 5 comma 2 in one array, 4 comma 7 in another array over here. For this guy also I can break it 2. One will be 1 comma 3. The next one will be 2 comma 6 over here, right? So now if you see, this guy is already sorted, this guy is already sorted, right? Now these two guys, between these two guys, this guy is already sorted, but this guy is not sorted, right? So I will again break it over here, okay, into 2. Now this array, yeah, only have 2 elements over here, right? That means I'll break it by 5 and I'll break it by 2 over here. Okay, so I cannot break it further over here because it is a single algorithm, right? So that means I will say my division, I cannot divide it further over here. Okay, so we will start from very lower node, basically leaf node. We will say, if I just talk about in terms of graph theory, this is a tree, right? So we'll start from the very leaf node position from here, and then we'll go up, okay, to solve this problem over here. And if you see, when I will apply the merge technique over here, right, to sort any of these levels over here, I will apply the similar technique over there. Okay, so when we divide a particular array into a sub array, as I said, we basically call them a left array and a right array over there, right? So we can say in the analogy of human, like we will say a left hand array and a right hand array. So merge sort algorithm is basically these two hand techniques only. Okay, so in your left hand you will have a array over there, in your right hand you will have a array over there, and you will just point it out in different elements to sort them out. Okay, so let us discuss that one now. Now to solve this, let us start from this leaf node only. Okay, so we divided this sub array 5 comma 2 into two sub array. One array has single element 5, another array has single element 2 over here. Okay, so let us write it down over here. Okay, I'll just try to say, it says solution, so I'll just try to create a section over here. Okay, solution. So what we'll do, let us try to create a table over here. Okay, so 4 element table. So I'll write it down over here, left hand. Okay, and I will write it down over here, right hand. Okay, so in our left hand we have a single element called 5. In our right hand we have a single element called 2 over here, right? So 5, I will just write 2 over here. Now in the merge sort technique, what happens is we basically compare, okay, each and every element in our left hand with each and every element of our right hand. We'll start with from the bottom element and we'll just go off from there. Okay, so we'll take one by one element in left hand, another element in right hand. We compare them. Okay, whichever is smaller, we'll just write it first. Okay, then again compare. Okay, it will be more clear when our array will have more element, okay, which eventually we will have when we will merge them to create a bigger array. Okay, so if we are exhausting from our hand, we will write down the other elements over there. Okay, in from one of our hand, we'll just write down the other elements, all other elements from the other hands. Okay, so that means if we see in our left hand we have 5, in our right hand we have 2. So which one is smaller? The right one is smaller, so I will write 2 first. Okay, and then I have exhausted my right hand, so I will write the whatever remaining portion we have in our left hand called 5 to create the final array 2 comma 5 over here. So iteration 1, I will just write iteration 1 over there. Okay, so in iteration 1 we created our final array called 2 comma 5 over there, right? So let us write it down over there. So we created a merged array called 2 comma 5 over here, right? From these two guys, we created this one over here, right? Now if you see this guy, we can apply the similar technique over there, right? Now in our left hand we will have 4, in our right hand we will have 7. So as 4 is already less than 7, the final array will be again 4.7, right? So I'll just not write it down again, so I'll just say, I'll just try to make it in a same way. This will be 4 comma 7 only, right? So this 4.7 produces another array called 4 comma 7. It is a similar in nature. Similarly 1 comma 3 and 2 comma 6 will produce the same array over there, right? So I'll just write it down. So 1 comma 3 will produce 1 comma 3 again, right? 2 comma 6 will produce 2 comma 6 again, 2 comma 6 again, right? I'll just make it as in a similar in a small line. Okay, that's fine, that should be fine. Okay, so after first merge we got these 4 arrays over there, right? Now we will try to merge these two guys and these two guys, because this is our new left hand, this is our new right hand. Again, from this to this is our new left hand and this is our new right hand, right? So let us try to write it down. So we are talking about iteration, let's just say paragraph over here, iteration 2 over here. Okay, so in iteration 2, so it will be a table of two elements over there, right? So in our left hand we have 2 comma 5, right? Now while writing it down, we'll write something like this. Okay, the smaller element will be the below one, the bigger element will be the first one. That means in descending order. Okay, and in our right hand, okay, we will have 4 comma 7. That means 7 will be here. If I just write it in descending order, so it will be easier to explain, basically nothing else. You can intuition wise there will be nothing different if we just write, if I just write 2 up, and if I just write in ascending order as well. Okay, so now let us try to reason through it. Okay, so we will start with we will take this element from our left hand, right? So we will just make it this guy, we will just make it a style. I'll just say this one, brown. Okay, so okay, so we have taken 2 from our left hand and we have taken 4 from our right hand over there, right? So we compare these two. Okay, so which one is the smallest one? 2. We will write 2 first over here. Okay, so in our new array we will write 2 first over here. Okay, so whenever we already written down over here, we will ignore this guy over there. Okay, so we will just ignore these 2. That means I will just make it in normal color, let's say, or maybe I'll just say red color. Okay, I'll just make it as red color over there. Now we have 2 over here. Now in our right hand we still have 4. Okay, now left hand we picked up 5 over here. Okay, so text style customized, I'll just write brown, or better I'll just write blue over here so that we will not be confused with the color. Okay, so we compare 4 with 5 now. Okay, so which one is the smaller? 4 is the smaller, so we'll write 4 over here. Okay, so when 4 is gone, we will just make it as red over here. Okay, so it will be cumbersome. I'll just keep it in this color only. So we already have 4 over here. Okay, so maybe better I'll just remove it so it will be easier now. Okay, so now in our left hand we have 5, in our right hand, so in our right hand we have 7. So okay, only we have these 2 elements left, right? So which one is the smaller? 5 is the smaller one, so I'll write 5. I'll remove 5 from here, right? So we exhausted our left hand, so you only have right hand. Okay, and if you see it over here, whenever we exhausted one hand, right, the other elements whatever we are seeing it over here, it will be already sorted, right? Because merge sort requires sorted arrays, input arrays, right? That's why we have done this divisions over here, right? So we can directly write the other elements over here. Okay, so we got 2 4 5 7, right, our final one. So I'll just give it back these guys. Okay, so that we will be in sync, right? So after iteration 2, that means after merging these 2 guys, we got 2 4 5 7, which is again a sorted array, right? So we'll just write it down over here. 2 4 5 7 over here, right? Again from here I'll just drag it, delete from here, I'll just drag it to the same guys over here. Okay, so we got the we merge these two guys over here. Now similarly, let us merge 1 3 and 2 6 over here. Okay, so I'll just write it down, another paragraph. It is our iteration 3 over here, right? So again we have two elements over there, right? So that means we have in our left hand and we have our right hand here again, right? So this time we have 1 comma 3, right? So if I just order it in descending order, it will be like this. And we have 2 comma 6, that means 6 and 2 over here. Okay, so again we'll apply our merge technique over there. We need to have our final array over here, right? So we will start with the left hand, the bottom portion of the left hand, right, and the bottom portion of the right hand again. So between this 1 and 2, which one is the smaller? 1 is smaller, so 1 I will write it over here. I will remove 1 from here. Okay, so in our right hand currently we have 2, correct? Now I will compare. I in our left hand I have to choose something, so I'll choose 3 over here. Now which one is smaller? 2 is smaller, right? So that means 2, I'll be writing it over here. Okay, so 2 is gone. Now in our left hand we have 3 over here. I will compare with only the right hand portion, which has 6, right? So 3 is smaller, so I'll write 3 over here. Okay, so when 3 is gone, we only have, we exhausted our left hand over here, so we only have 6 over here. We'll write 6 over here. Okay, so I'll just give it back again. So 3 and 1 we have, right? Okay, yeah, 1 and 2 over 6, right? So we got this array over here, 1 2 3 comma 6. I'll just copy it from here. I will just create the same array, right? 1 2 3 6 over here. I'll create the same relationship over here as well. Okay, so we got from these 4 sub arrays, we got 2 sub arrays which are again sorted, right? So that means we again in our left hand we have an array which is having 4 element. In our right hand we have array which is having 4 element again, right? So we have to iterate through, right? If you see over here, whenever we are solving these small arrays recursively, right, by using the same technique over there, right, until and unless we are getting the final result over here, right? So let us do it now. Again, there is no harm of doing it. So I will just write it, this paragraph again. So we are talking about iteration 4 here, right? So in iteration 4 I have 4 elements in our left hand and right hand. Okay, so let us do it. So our table will be 5 into 2, correct? So in our left hand, similar way we will write right hand, here. So in our left hand, if I just arrange it in a descending order, 7 5 4 2, correct? So 7 5 4 2 here. In our right hand we have 6 3 2 1, correct? 6 3 2 1 here, right? So now let us apply the similar technique. So we choose 2 from our left hand and 1 from our right hand, right? Which one is smaller? 1 is smaller. I'll write 1 over here. Okay, I'll just delete it to make it more useful. So we still have 2 in our left hand. We will choose right hand, this 2 over here, right? Now either as this is a tie case, right? So we can write anything over here. I'll write this 2 guys, 2 over here. Okay, now this 2 will be vanished Now in our right hand we still have 2, right? From our left hand we'll pick 4 over here. Okay, which one is smaller? This 2 is smaller. I will write this 2. Okay, I'll delete this 2 now. So in our left hand we still have 4. Right hand we will pick 3. Which one is smaller? 3 is smaller. I will write 3 over here, right? So our right hand is getting emptied fast, right? In our left hand we still have 4. Okay, in our right hand we have 6, right? Which one is smaller? This guy is smaller. I will write 4 over here. Okay, so I'll remove this one. Now in our right hand we still have 6. In our left hand we will pick 5 now. Which one is smaller? 5 is smaller. I will write 5 over here. Okay, I will delete it. Now in our right hand we still have 6. Left hand we will pick 7 now. Which one is smaller? Right hand is smaller now. We will write 6 over here. Okay, we'll empty the right hand now, so I can write whatever is there in our left hand directly over here. If there are more than 1 elements, I can write in similar order. Okay, but as I have written it in descending order, you have to remember that this array always by default we are arranging in ascending order. That means from bottom to up you have to write. That's all. Okay, so we created our final array from this one. Okay, so this will be our final array after all these merge operations, right? 1 2 2 3 4 5 6 7. Okay, so if you see, this is already in sorted manner, right? So if I just write it to make this complete, so we got our final array from this array over here. Okay, we got our final array over here, right? And what we have done, we basically divided this whole problem into small sub problems until and unless we are getting a array which is sorted basically, right? If I get a sorted array, I will not divide it further because my merge technique requires a sorted array over there to work on it. Okay, why it requires? Because of this logic over here. Okay, I'll just make it complete over here. 7 5 5 4 2, so that when I'll just share with you guys this lectures and this materials, it will not be empty. 6 3 2 1. Okay, 6 3 2 1 over here. Okay, so if you see over here, so we just divided this arrays until we get a sorted array over here. Okay, and if you see over here, we divided till the single element, and single element is always sorted by nature, right? Because we have only single element over there, so that's why we have not divided it again, right? And after dividing, and each and every steps over here, if you see this ash colored steps over here, right? So over here we have done the merging part, right? So from the division, so if I just say from here, okay, so from here, I don't know whether I will be able to do it or not. No, I will not be able to do it. So this portion is the division part. This portion is the merging and combining part, right? That means conquering and combining part together, right? Where we are basically combining these two arrays over here into by applying the merge technique recursively, okay, to get the another sorted array until and unless we are getting our final sorted array over here. Okay, so hopefully this video is helpful. So here in this video I just try to give you the intuition behind the merge sort algorithm. In next videos, what we'll see, we will try to develop the pseudocode for this merge technique. Okay, we'll try to understand the different internal stuff over here, how the pseudocode works. Okay, and also we will try to understand the analysis part of it, like how much time it takes this particular algorithm. Okay, so just for your question, like what do you think, how much time it will take this one? If you remember, for the insertion sort it takes n square, right? So how much time it will take over here? Just a question. Try to think about it. We'll discuss in future videos. Okay, see you in next video.